general relativity, step by step. I'm trying to demand, well, I am demanding, that the covariant divergence of this term here is equal to 0. And we've discovered that this lambda term here can be anything we like, so I'm just going to ignore it. So what have I got now? What I've got now is, what have I got left? I've got the Ricci tensor alpha beta plus some undetermined constant which I'm going to investigate. That's a constant which I don't know, times r times g alpha beta covariant derivative with respect to beta equals 0. I'm going to find a b that makes this work. What are the dimensions of b? I think the dimensions, yeah, b must be dimensionless, of course. So b might be something like root pi or minus a half or 0.1 or something. Oh, it might be 0. Oh no, it can't be 0. If it was 0, we've established that b cannot be 0. But we don't know anything about b, it's just a constant. So how do we find out what this is? Well, we start with the Bianchi identities. They're very useful, the Bianchi identities. Bianchi. Even now I say Bianchi in my head and that's wrong. Alright, so I'm just copying off my notes here and I'm just going to write down the Bianchi identities. We've got R, now which way around have we got? We've got alpha, beta, mu, nu. Alpha, beta, mu, nu, semi-sigma plus R. Alpha and beta stay the same and everything, these terms go one to the right. So we've got sigma, mu, semi-nu. Bracket. You don't need brackets. You don't need brackets, but I'll put them in anyway. Plus bracket R. Alpha and beta stay the same, and they go one step to the right again. So nu comes and joins there. What's next? Sigma, semicolon, what's left? Mu. Equals 0. And they're the Bianchi identities. Now I've got 5 downstairs indices in this equation here. 5 downstairs indices. And I want 2 upstairs indices. So what I'm going to do is, by judicious choice of metric tensor, I'm going to multiply this equation by a whole sequence of metric tensors, and what we're going to find, well, let's just do it first. Gamma sigma g alpha mu g, just copying from my notes here, mu. So what I'm trying to do is to raise 3 of these indices. 3 of these indices, and what we're going to be left with on the top, the sigma cancels out with that, or sums over that sigma there, that's free. The mu sums across with that mu there. Oh no, we've got an alpha as well, so we're summing with respect to alpha. And beta nu, what have we got? Beta nu. Beta is that one and nu is that one. So what have I got left here? We've got 1, 2, 3, 4, 5, 6. We're just going to have a gamma on the top, I think. Well, let's just get on with it. Let's just do this multiplication. I'm going to call it A, B, and C and see what happens. So what's A equal to? Well, it's G gamma sigma, G alpha mu, G beta nu times R alpha beta mu nu semicolon sigma. Which equals, by definition, it equals G gamma sigma times this term here, which by definition is equal, well, no, never, I'll do it slowly, It's G alpha mu, G beta nu, R alpha beta mu nu, semicolon sigma. Why can I do that? Because the covariant derivative of the metric tensor is equal to 0. So it commutes past a semicolon differentiation. Now this is equal to G gamma sigma times the Ricci tensor with What's left? Mu at the top, beta's gone. Sorry, I'm getting myself a bit tangled up now. This thing, by definition, is the Ricci tensor. And so what we have now is equal to G gamma sigma, which is this term here, times the covariant derivative of the Ricci scalar, the curvature scalar, I'm sorry, which equals G gamma sigma R semicolon sigma. Okay, so we've been through this rather complicated sequence of results, and what I'm trying to do is to identify these terms here, and I've determined what A is. I've done that one. Now I need to work on B and C. So let's just write those down. It's R alpha beta, copying from here, sigma mu semi nu plus R alpha beta, which doesn't change, nu sigma semicolon mu. And I need to simplify this. Let's just have a look at that and see what we can make of that. Okay, so we're trying to simplify this. Now, what else did I do? What else did I do? We were multiplying it by this tensor here. So let's just write that out and see what happens. G gamma sigma, G alpha mu, G beta nu times R alpha beta sigma mu semicolon nu plus R alpha beta nu sigma semicolon mu. I want to simplify that beast there. What an awful thing that is. What I'm going to do is simplify it. But this screencast has already gone on too long, so I'm going to stop here and do it in the next one. I want to simplify this. Simplify. And of course we've got lots of tools at our disposal. This is the second and third term in the Bianchi identities, and I multiplied it by these three metric tensors here, just to make the other term nice and easy. So hopefully we can multiply this term by the same product of t's, and it will similarly be nice and easy. Well, we'll see about that. Okay, well, I'm going to stop here. Stop.